2006, Manhattan didn't just get a building. It got a promise. A 58-story residential tower rising 670 feet above the financial district, unobstructed views of the Brooklyn Bridge, units starting at $1 million. The developer called it a bold statement in glass and steel. The architect called it a triumph of modern engineering. The marketing team called it the future of luxury living in New York City. The building called it something else. Today, 161 Maiden Lane stands in Lower Manhattan like a question nobody wants to answer. It is 670 feet tall. It is structurally compromised. It has never been fully occupied. Marble panels have fallen from its facade, some weighing hundreds of pounds, crashing onto the sidewalks below. The city has declared it a public hazard. Protective netting wraps its lower floors like a bandage on a wound that never closed. And the building bends. Not dramatically, not in a way you'd notice walking past, but stand far enough back, look carefully at the profile against the sky, and the tower curves, slightly, unmistakably, like a pencil balanced on its eraser and left to drift. Engineers call this a lateral deflection. New Yorkers call it the banana building. $250 million was spent building it. Hundreds of millions more have been spent fighting over it. And the building remains unfinished, uninhabitable, unbending in its refusal to either be fixed or fall. This is the story of 161 Maiden Lane. And it begins not with corruption, not with negligence, but with something far more dangerous. It begins with a shortcut that looked, on paper, like genius. The original sin. Every engineering catastrophe has a moment, a single decision buried in a spreadsheet or a meeting room that seems reasonable at the time and catastrophic in retrospect. For 161 Maiden Lane, that moment was a choice about the ground. Manhattan sits on some of the most reliable bedrock on Earth. Schist, dense, ancient, crystalline, metamorphic rock that pushed up from the Earth's crust hundreds of millions of years ago. It's why Manhattan can hold skyscrapers at all. Midtown's bedrock is close to the surface. So is downtown's. The island was built to carry towers, but between those two bedrock plateaus, in the area around Maiden Lane, the schist dips. It drops down, sometimes 150 to 200 feet below street level, beneath layers of fill, sand, and soft glacial sediment deposited after the last ice age. You can still build there, but you have to go deep. You have to find the rock. The original foundation design for 161 Maiden Lane called for caisson foundations, massive concrete shafts drilled all the way down to bedrock, expensive, time-consuming, unglamorous, the kind of work that costs millions and produces nothing the marketing team can photograph. So the developer, Fortis Property Group, switched. Instead of caissons to bedrock, they used jet grouting, a technique where high-pressure water jets break up the soil and mix it with cement to create a stabilized column. Think of it like stirring concrete into a milkshake and hoping the milkshake holds up a skyscraper. It works in some conditions. It works when the soil is appropriate, when the engineering is conservative, when the loads are modest. The load here was not modest. It was a 58-story, 670-foot glass tower. The savings from switching foundation systems, approximately $6 million. $6 million. On a $250 million project, a 2.4% budget optimization that engineers would later estimate contributed to hundreds of millions in damages, years of litigation, and a building that the city of New York has repeatedly called unsafe for occupancy. $6 million. The original sin of 161 Maiden Lane was not stupidity. The engineers weren't incompetent. The decision made financial sense inside a spreadsheet. But a spreadsheet doesn't feel the weight of 670 feet of glass and steel pressing down through soft glacial sediment. The schist does. And the schist was not consulted. The physics. Here is what happens when you build a skyscraper on stabilized soil columns instead of rock. The building settles. All buildings settle. Even ones on bedrock move fractions of an inch as the concrete cures and the loads distribute. That's expected. That's designed for. What's not designed for is differential settlement, when one side of a building sinks faster or further than the other. Imagine driving 4 nails into a tabletop to support a heavy glass sheet. 3 nails go into solid oak. The 4th goes into balsa. Now pile books on the glass. 3 nails hold perfectly. The 4th compresses slowly, gradually, inevitably. The glass tilts, not much at first, then more. The tilt redistributes the load. Now more weight shifts toward the soft corner, which makes it compress further, which makes the tilt worse, which shifts more weight. That is a progressive settlement cascade. And that, in broad mechanical terms, is what began happening at 161 Maiden Lane almost immediately after construction loads were applied. But the physics didn't stop at settlement. A 58-story building is not a rigid block, it flexes. Wind pressure alone causes the upper floors of a tall building to sway feet in either direction. This is designed, this is expected, this is why skyscrapers don't snap in half during storms. But when a building's foundation settles unevenly, it introduces a permanent lateral bias into the structure. The building doesn't just sway, it leans toward its bias point and stays there. The technical term is eccentric loading. The informal term is the building is bent. And a bent building has a problem its designers never anticipated: its own cladding. The exterior facade of 161 Maiden Lane was clad in large panels of the thin marble. Beautiful, expensive, photogenic. Marble is rigid, it does not flex. When the building beneath it began to move, settling, leaning, cycling through thermal expansion during New York's seasonal temperature swings, the marble panels couldn't follow. They cracked. They separated from their anchors. They fell. Thermal hysteresis, the lag between a material expanding in heat and contracting in cold, means marble panels on a moving building face stress cycles every single day. Summer heat expands them. Winter cold contracts them. Each cycle, the anchors loosen fractionally. After enough cycles, the panels detach. The first panels fell in 2019, then more. Then the city intervened. Protective nets were installed around the lower floors. Residents of neighboring buildings were warned. Pedestrians were redirected. A $250 million tower was dropping its skin onto a Manhattan sidewalk. The building wasn't collapsing. It was something more insidious. It was slowly, methodically disassembling itself, panel by panel, anchor by anchor. While the lawyers argued and the engineers filed reports and the building stood there, bent and patient, shedding its beautiful exterior like a snake that had nowhere to go. The deadlock. Here is where the story stops being about engineering and becomes something older. Something almost mythological. 161 Maiden Lane is caught, frozen, trapped in a legal and economic amber that no amount of money or ingenuity has been able to dissolve. Can it be fixed? Theoretically. The foundation could be underpinned. New, deep piles driven to bedrock, the building's base stabilized, the lateral lean addressed. The facade could be stripped and reclad in a material that tolerates movement. The structural compromises could be remediated, floor by floor, system by system. The cost of doing all of this. Estimates range from $200 million to over $400 million. On a building whose current market value, compromised, uninhabitable, litigation clouded, is a fraction of what was originally invested. The mathematics do not work. They have never worked. Every party that has examined the numbers has reached the same conclusion. Fixing this building costs more than the building is worth. Can it be demolished? Also theoretically, yes, but demolishing a 58-story tower in the middle of Lower Manhattan, surrounded by occupied residential buildings, active subway infrastructure, the East River waterfront, and one of the densest urban environments on Earth, is not a weekend project. The logistics alone would require years of planning, hundreds of millions of dollars, and a level of coordination between city agencies, neighboring property owners, and infrastructure operators that makes the original construction look simple. And who pays for it? That question has been the subject of lawsuits, countersuits, arbitration proceedings, and legal battles that have consumed years and generated legal fees that rival the original construction budget. Fortis Property Group, the original developers, the contractors, the subcontractors, the insurance carriers, the city. Every party has pointed at every other party. Settlements have been reached and broken. New claims have been filed over old claims. The building stands in the center of all of it, patient, bent, unmoved by human argument, while the lawyers bill and the panels fall and the nets catch whatever comes loose next. This is what legal amber looks like at 670 feet. A building too broken to live in, too expensive to fix, too complicated to tear down, and too tall to ignore. It just stands there, shedding. Let me tell you what $6 million actually bought. It bought the illusion of efficiency. It bought a foundation system that worked on paper, in a spreadsheet, in a budget meeting where the geotechnical report was in a binder that someone had skimmed. It bought a shortcut through the part of the process that nobody photographs and nobody celebrates. The part that goes 150 feet underground and touches schist that has been there since before mammals existed. It did not buy what it was supposed to replace. And now, that $6 million in savings has generated an accounting ledger that no one in the room that day could have imagined. $250 million spent building it. Hundreds of millions in litigation. Remediation estimates pushing $400 million. Years of lost revenue on units that were sold, refunded, sold again, and eventually abandoned. A building that generates legal fees faster than it could ever generate rent. The Greeks had a word for this: hubris. Not arrogance in the crude sense. Not the arrogance of a villain who knows he's wrong and proceeds anyway. The specific, tragic arrogance of a person who is completely, genuinely convinced they have found a smarter way. Who looks at bedrock 155 feet below street level and sees not a foundation, but an inconvenience. Who looks at $6 million in savings and sees not a risk, but a triumph. Hubris doesn't announce itself. It arrives dressed as efficiency. It comes with spreadsheets and confidence and a foundation report that technically clears the threshold. It shakes hands in a conference room on the 40th floor of a building that is itself standing on bedrock, and it makes a decision about a different building that will stand on something softer. And then the physics begins. Not immediately, not dramatically. Slowly, quietly. A millimeter of settlement here. A fractional lean there. A marble panel that takes 7 years of thermal cycles before it finally separates from its anchor and falls 60 feet onto a Manhattan sidewalk where it shatters on concrete that doesn't care about the meeting that caused it. 161 Maiden Lane is not a cautionary tale about bad people making bad decisions. It is something more disturbing. Good people making a rational decision that ignored the one party that doesn't negotiate. The schist. The schist was always there, 155 feet down, ancient and indifferent, carrying the weight of every proper building that found it and utterly indifferent to the ones that didn't. It didn't move when the jet grout columns were poured above it. It didn't warn anyone when the loads began to shift. It simply sat there, as it has sat for 400 million years, while above it, a tower bent slowly toward the sky and the humans who built it argued about who was responsible. Gravity doesn't file briefs. Soil mechanics don't attend depositions. The Earth doesn't renegotiate its terms because the budget needed trimming. The banana building will stand in Lower Manhattan for years more. Probably. Most likely. Wrapped in its nets. shedding its panels, housing its legal disputes. A 670-foot monument to the precise moment when human confidence and geological reality stopped agreeing with each other. The schist is still down there. It always was. It's still waiting to be asked.